10 steps for gravity. I will show you an example so we can see how does the graph will look at the end, and I will explain you each step. We have a function 3x to the square minus 5. First we have to cut the domain. To cut the domain, we have to see if we have restrictions. We have different restrictions. If you have something over x, you will get a restriction. So x couldn't be 0 because in the bottom of this you can have 0. Okay. This must be bigger than 0, bigger or equal. And if you have both, then it has to be only bigger than 0, okay? So with all of that, in this specific function, we don't have a restriction. So our domain will be minus infinity to infinity. We have the symmetry. We have two types of symmetry. The first one is odd, where all the x's change from positive to negative or the other way around, negative to positive. Okay, already the other way. Or you can have even. Even is when x stays the same way, okay? So we will do it with this function, okay? F of negative x, it's equal to 3 minus x to the square minus 5. So f of minus x is equal to 3. Because you elevate to the square, it will continue to be positive. So x to the square minus 5. So this has a even symmetry. Then we have to get the x and y intercepts. Here we will make that forget the x-intercepts, it's when y is 0. So we will get the function equals to 0. 3x to the square minus 5 is equal to 0. So 3x to the square is equal to 5 because it passes positive. X to the square is equal to 5 over 3. And finally, x is equal to the square root of 5 over 3. And this is our x-intercept. So a square root of 5 over 3 and 0. This is x and this is y. And to get the y-intercepts, we will put 0 where are the x's. So y is equal to 3, 0 to the square minus 5. This is eliminated because everything times 0 is 0, and y is equal to minus 5. So when x is 0, y is minus 5. Okay, one thing I almost forgot is this is a real number, then it will be a gap. And if you got something else, then you don't have one thing. If you have 0 over 0, it's a gap. If you got a number over 0, then it's an asymptote or horizontal asymptotes. Here we have to change everything to infinity, okay? So f of infinity is equal to 3 to infinity to the square minus 5 is equal to infinity. So our asymptote is in infinity. That means that there is no asymptote. For this limit, we have different cases. I will show you three, okay? X to the square over x must look like infinity to the square over infinity. So this 2 is bigger than this 1, so the answer is infinity. When you got 3x over 2x, then you got 3 infinity over 2 infinity. So the answer must be, because this one and this is 1, 3 over 2. And the last one is when you got x over x to the square, then your answer will be 0, because it's infinity over infinity to the square. This 2 is bigger than this one, so then it's 0, okay? Okay, this is the first, so this is bigger than this, so it's infinity. This, it's 1, and it's 1, they are the same, so you get the numbers 3 over 2. And in the third example, the 1 is less than the 2 that is down, so the answer is 0. Let's continue. This is a critical point. So we derivate the original equation. Okay, it's 3 times 2, 6, and x, okay? So it's a derivate because 5 is 0 because it's only a number, okay? So we equal this to 0, 6x equals to 0, x is equal to 0. So we substitute this 0 in the original equation, okay? So f of 0 is equal to 3 times 0 to the square minus 5, that is minus 5. So it's 0, 5, minus 5. And this is x, and this is y. This is our critical point. In this part, we substitute to 0. So we can get the y. When x is 0, y is minus 5. So now we got a point. Our last step was to get the critical point. So we got the first derivative. In this, we have to test it. So we will choose one point that is not 0 because it's our critical point, and we will substitute here, okay? So we can know if our point is a maximum or a minimum, okay? So f of 1, that is an easy number, over, it's equal to 6 times 1, equal to 6. This is positive, so the graph at point number 1 will go upward, okay? Then we can see that our point is a minimum. Minimum, it's 0 minus 5. Okay. For getting inflection points, you have to get the second derivative. This is our first derivative, okay? So this will be equal to 6. 6 is a number, so we don't get x. So we don't get no inflection. But we are making an explanation from other things. So I will explain you a case where we can get something. We will put x to the cube minus 2, okay? This is our function. I will put it another color so you can notice the difference, okay? So we derivate f to the x is equal 2x to the 3x to the square, and this is limited. This is 3 times 1, it's 3, and we subtract 1, okay? So this is our first derivative, and our second derivative, it's 2 times 3, 6x, okay? So we equal this to 0, okay? 6x equals to 0, x equals 0 over 6, x is equal to 0. So we got that our x is 0, and we substitute here to get the point where when x is 0, what will be y, okay? So f of 0 is equal to 0 to the cube minus 2. This is equal to minus 2. So our inflection point will be minus 2. Sorry, the other way around. 0 minus 2, x and y. Number 9, concavity. We don't got an inflection point, so this we won't get concavity. So here is no concavity. But this is an explanation video, so I will use this example to get the concavity, okay? So with the second derivative, we will test any point that it's between this and the critical point, okay? So here we don't got the critical point, so I will get it fast. Got our critical point and this. This is the same, okay? But we will get another point. So f of, I don't know what number, 2, that's equal to 6 times 2, that is equal to 12, but this is positive, okay? So we have a positive concavity and 2. Okay, our last step, we will graph and get the range. We have domain, symmetry, intercepts, vertical asymptotes, horizontal asymptotes, critical points, first derivative point test and extreme points, inflection points, and concavity. I have already said we graph the interceptions and we don't have vertical and horizontal asymptotes. Our critical point is the same as the interception. Our first derivative test. Okay, when x is 1, it goes upwards. So the graph will look like this. And if we have seen this, the symmetry is even. We almost forget an n. So it's even. So it's the same way in the other side. So at the end we got a parabola. Okay, so we will look like a parabola. At the end, the range will be -5 because we start over here, and the parabola will go upwards until infinity.